we'd seen in the last video that the amount of solute that you could dissolve in a solution, the amount that could be dissolved in a saturated solution, was dependent upon temperature. That for solids, if you increase the temperature, you can dissolve more solute. This can be described by a solubility curve. This is the solubility curve for potassium nitrate. This says the number of grams of solute that can dissolve in 100 grams of water. So this graph, or this curve for potassium nitrate, is showing that at 10 degrees Celsius, you can dissolve 20 grams of potassium nitrate in 100 grams of water, and that at 60 degrees Celsius, you can dissolve 80 grams of potassium nitrate in 100 grams of water. So, considering these facts, answer the question, how many grams of potassium nitrate can be dissolved in 200 grams of water if it's at 60 degrees Celsius? So, at 60 degrees Celsius, you see that you can dissolve 80 grams of potassium nitrate in 100 grams of water. So, 80 grams of potassium nitrate can dissolve in 100 grams of water. How many grams of potassium nitrate can dissolve in 200 grams of water? So this is just a proportion. We know that there's a direct relationship between the amount of water that is dissolving your solute and the amount of solute that can dissolve. So we saw in the last case that if we double the amount of water, we could double the amount of sugar that could dissolve. Similarly here, if we have twice as much water here, we should expect to be able to dissolve twice as much potassium nitrate. So this is described by a proportion here. This is showing a direct relationship. You can take this proportion and cross multiply, or you can rearrange it to get 200 grams of water on top. So multiply both sides by 200 grams of water, so that you say, if I have 200 grams of water, and for every 100 grams of water, I can dissolve 80 grams of potassium nitrate, how many grams of potassium nitrate can I dissolve? So 200 over 100, or 2. If we have twice as much water, we should be able to dissolve twice as much times 80, or 160 grams of potassium nitrate. So we see that there is this relationship between how much that can dissolve and the temperature. So consider a case, consider a case in which we're at 10 degrees Celsius and we have 100 grams of water. We have a saturated solution where we're only able to dissolve 20 grams of potassium nitrate, and we might have, say, 50 grams of potassium nitrate left over undissolved at the bottom as solid. So you've got only 20 grams dissolved and 50 grams down at the bottom, but if we were to increase the temperature to 60 degrees Celsius, we should be able to dissolve up to 80 grams of potassium nitrate in 100 grams of water. And so we should be able to dissolve all of this potassium nitrate, 20 plus 50, a total of 70 grams of potassium nitrate dissolved. And we're able to do that because we could dissolve up to 80 grams. We had started with a saturated solution, but by increasing the temperature, we got an unsaturated solution, one in which there was no solid at the bottom. But what if we were to decrease the temperature back to 10 degrees Celsius? Now, you might expect that being back at 10 degrees Celsius, like before, we would have 50 grams of solid at the bottom, but actually, oftentimes, if you decrease the temperature from when you had an unsaturated solution, in which all of the solid was dissolved, the solid will not precipitate out. The compound will remain dissolved. The reason that it can remain dissolved, even though at 10 degrees Celsius we should only be able to dissolve 20 grams of potassium nitrate, as described by our solubility curve up here, we should be able to only be able to dissolve 20 grams of potassium nitrate in 100 grams of water at 10 degrees Celsius. In theory, we should only be able to dissolve this much, but we are dissolving much more than that. We would say that this solution is supersaturated. It's super full, where the definition of a supersaturated solution is one in which we have more solute dissolved than is theoretically possible for a given amount of solvent at a given temperature. Now, the only way to, or actually one of the ways of getting out of having a supersaturated solution, getting back to the theoretically possible saturated condition, is to add a seed crystal where it provides some surface on which the potassium nitrate here can dissolve. So this potassium nitrate remains dissolved. It doesn't crystallize out. It doesn't build into solid because there are no surfaces to crystallize upon. One thing that you could do is, yes, add the seed crystal, drop it in. And when you drop that seed crystal in, there is a solid on which the potassium nitrate can now build upon. And so it will build a crystal quite rapidly and give us, or take us back to having a saturated solution where we have 50 grams at the bottom and only 20 grams dissolved for that given 10 degrees Celsius. Another common thing is to scratch the surface of the glass, and this can create a solid or a surface on which crystallization can occur. Now, for AP students here, we can recrystallize compounds where we might have some impure compound where you have A and B together. And what you can do is you can dissolve all of it by adding solvent or by heating it up in solvent, and then slowly cool it down and perhaps add a seed crystal, add a little piece of A. If you add a little piece of A, now there is A on which all the other A can build upon, and so you should get just solid A, and the B should remain dissolved. This is a nice way of purifying your compound A, separating it from that B. The B remains dissolved, and the A is pure solid. All right, thanks for watching, guys.